Hello there, this is exercise 3D. We're going to look at quadratics again, this one quadratic inequalities. And all the time we're just stepping up the level of difficulty of this. So we've looked at the equation, we've looked at factorization, we've looked at completing the square, we've looked at trying to draw them. And we're going to try and combine a few of those techniques with inequalities now. People often get this wrong, so be warned. Now, to start with, we've got a little starter on simultaneous equations. I'll do one with you here, just and you can practice the other two. Now you try to make sure you have the same number of y. So here I have, or it doesn't have to be y, it can be x. But here I've got the same number of y. But here I haven't. So on this one, this might be a better one to start with. Let's do this one. So on this one, you're meant to, I'm going to times this one by 3. Because that will give me 6p, and that says 6p. So rewrite them. And the bottom one actually changes. You'll notice you have to times everything by it. Times equals 33. Now, this thing up here says if the signs are the same but the thing you're trying to get rid of, subtract them. But if the signs of the thing you're trying to get rid of is different, then add them. I think I mentioned this in class. So you'll notice the signs I'm getting rid of p's. They're both minuses, so they're the same. So I'm going to subtract. And I've got my big numbers at the bottom, so I'm going to subtract going upwards, which is a bit weird, but there you go. 9n take away n, that's 8n. That goes, that's why we do it. 33 take away 1 is 32. And straight away you can see, and n is 4. Done. Oh, be warned, I still need to now sub it back into one of these. Now, to be honest, neither of them are any good. They're not very nice equations, but I'll go into the one with the smallest numbers. So if I put that into the n minus 6p equals 1 formula, then I'll say 4 minus 6p equals 1. I'm going to switch those two around actually. I don't like it the way it is. I'll just put it up here. So I'm going to write 4 minus that 1 equals 6p. And that's a plus, you see. So that'll become a minus. That's a minus, it'll become a plus. So 6p equals 3, p equals a half. And there's my answers. So hopefully you can do all of those. Hopefully you get those answers and you can then move on to the main part of quadratic inequalities. Now, quadratic inequalities in itself are quite important, so I'm going to see if, I don't think this lets me run this. So if you get a chance, perhaps we'll have a look at this in class. This is quite a useful graph plotter where you can see what's going on. But we'll worry about that in class. So for now, for this PowerPoint where we're doing it now, let's have a look at this question. Now it says, first of all, always draw a sketch. A sketch is so useful, which is why you'll see on that last plotter that they were drawing sketches. But it says x squared plus 2x is less than 3. Well, first of all, I don't like it if it's not got a 0 on the right hand side. So I'm going to immediately do that. Where I say it's. And the other thing I do is I tend to ignore the less than initially, and I think of it as equals. And these things are equals, you can always factorize. Really, I say always factorize, you're likely to be able to factorize. I've got 3 at the end, so I've got 3 times by 1 is my only option. And I need to make a 2. Well, obviously, it's x plus 1 times by x minus 3. That will give me, oh no, I've got it the wrong way around. It's a minus 1 and it's a plus 3. Because I need to get plus 2 in the middle. And when you do that, then you get x equals 1 and x equals minus 3 in terms of what the graph looks like. So that's probably the best way of describing what I've just done. So at 1 and at minus 3. Now this is an x squared, so we should by now know that it's going to look something like that. There's my 1, there's my minus 3. And the fact that it says minus 3 here as well tells me it crosses here at minus 3. So I've got a lot of information just already. And notice, we want to know when this curve is less than 0. Less than 0. Well, just look at the picture. When's it? This is what we call the 0 line. So when is that curve lower, less than, under that straight line, that 0 line? And you can see anywhere between these 2 points is underneath it. So I'm going to say the answer is anywhere between minus 3 and x and 1. Now it can't be equal to it, there's no equal sign. That's the answer. Oh, there's my posh graph. And that's the answer. Good. So I've overlapped it a bit, but you get the idea. Right, now this one I much prefer because it says it's got the 0 on the right hand side already. It's worded differently. What's the range of values for which this is true? But it's the same idea. Basically, find the values which make this greater than or equal to 0. So if I just, again, pretend it's equal, I'm going to factorize it. And if I factorize it, I get an x at the front of both of them. And again, I've got a 5. There's only a 5 and a 1 I can play with, and I want to make it minus 4. So I reckon it's plus 1 and minus 5. That will give me a minus 4. So therefore my graph will cross the x-axis. X equals minus 1 and x equals 5. So let's draw it over here, I think, this time. So minus 1 is there. 5 somewhere over there. Notice again it's a positive x squared, so therefore we know it's a U shape. And it crosses at minus 5 eventually, so this is going to be what it looks like-ish. And that is minus 5 as well, because of this number here. Whatever that number is about the x, that's where it hits the y-axis. So I've drawn it, and it says when's it bigger than 0? When's it above the 0 line? That's really what it's saying. There's my 0 line. You can see it's above there and there. So in terms of my x values, there onwards, and there on that left hand side. So my answer to me here is it's x is greater than, it can be equal to actually, because it was allowed to be equal to here, or x is less than or equal to minus 1. There's my graph. Notice how I've done it in blue on my posh graph here. It's that side or it's that side. There you go, same answer. Okay, I've written the other way around, but that's fine. So notice those two cannot be combined. On my last example, let's go back to my last answer. My last answer was it was between these two things. Now, you can write it like that on ones which is, you know, you can see my picture in between here and here. The blue line is underneath. On this one, it's two separate parts. It's there or it's over here. So notice you can't join these two statements together at the end. Next question, find the range of values for which 4x minus x squared is greater than 0. So again, I'm trying to factorize it, but interestingly, I can see an x goes into both on both of these. Now, usually you get x squared plus 6x minus 12 or something like this, and you get this number at the end, and that number hasn't got an x, so therefore you can't factorize simply. But because there's no number, it's just x, so many x and an x squared, I can just factorize with one bracket. What a bonus. Makes it a lot easier. 4 minus x goes in the bracket. That means this gets me a 0, and this gets me a 4. So my graph, again, let's put my graph over here. I did last time, it looked okay. So it hits at x is 0, and it hits at x is 4. Now, be warned. Very tempting to go and draw the graph like that. But notice this is a minus x squared. And whenever you get a minus x squared graph, it looks like that. Of course, we already know that if you get an x squared graph, it looks like that, a U shape. This N shape is what you get if you get a minus x squared. So I must have a graph that does something like that. Okay, between 0 and 4. What's it say? When's it bigger than 0? Well, you can see in between these values, it is above the 0 line. It's above it. Between 0 and 4. So my answer here is it's between 0 and 4. Can it be equal? Let's have a look. Well, no, it can't. It's just as greater. So I can just have those single lines there. And that's my answer. There's my posh graph. And it's between 0 and 4. There you go. Find a range of values for which x squared is more than or equal to 7. Leave your answers in surd form. Okay, it's easy enough done. Now, there's a variety of ways of doing this. It's probably easier just to go, because there's nothing else there, I just want to square root it. So if I was to square root it, I'd go x is more than or equal to root 7. But it's not technically true, because whilst it is true, there's also, or x is less than or equal to minus root 7. Because we know there's a plus or a minus when you do a square root. Now notice, that's not an obvious thing. So it might be better, you know, to come over here and just say, let's rewrite this. So I've got x squared is greater than 7. I'm going to move the 7 over there, it becomes a minus. Hopefully this will make you realise why I've written it like that. So this is greater than or equal to 0. And this is like the difference of two squares. It doesn't look like it, but if it was x squared minus 9, hopefully you'd know this is x plus 3x minus 3. And that's because 3 squared is 9. Now, this is not so nice. But I can write x plus root 7 if I want, and x minus root 7, because root 7 times root 7 is 7. It's not so pretty though. When is that greater than or equal to 0? Well, obviously x. We kind of know this is going to give me x is minus root 7 and x is root 7 when I draw the graph. So if I draw the graphs very briefly for you, minus root 7 is about there, root 7 is about there. It's an x squared graph, so there you go, minus root 7 and root 7. Now, when is this bigger than or equal to 0? You'll notice it's bigger over here, because there it is, and it's bigger over here. There it is. So from here, and from my picture, I can now write x has got to be less than or equal, because it's on the left of there, minus root 7, or x is greater than plus root 7. And that's what I got over here in one easy step. And you might be wondering why I did that. I only did this to try to justify to you why we end up with two answers, one that said less than, one that said greater than. Because I don't think it's obvious as to why. But as soon as you do complete the square like you would have done perhaps with a simpler expression, then it becomes obvious. It's the same as all those others. So just look out for those. Notice I left it as in root form because that's what it told me to do. There you are. So that's the end of this exercise. We might have a look at that app that shows you a bit more detail in the lesson. So hopefully that all makes sense. So best luck.